initialize Genesis sequence.
Today I'm going to talk about AsyncAPI and Springwolf. But before, I'd like to ask you all a question. Is this your first time at DevOps? Could you raise your hands if it is your first time? Yeah? Cool. This is my first time. And actually, I didn't even know that this was a cinema, which makes everything a little bit more overwhelming, you know? But we don't have too much time today. We only have 30 minutes, so I'm going to try to be real quick and get to the point as soon as possible. But before we actually get to talk about AsyncAPI and Springwolf, I'd like to ask you another question, and that is, have you guys seen this kind of architecture before? Could you raise your hands if you have? So basically have the application layer on the top, the presentation layer on the top, the application layer in the middle, and then the database layer on the bottom. I saw that many people raised their hands, so this is a pretty common and universal architecture. Most people have worked with that. I honestly believe everybody here has worked with such an architecture, right? And that makes me wonder why this architecture is so common and universal nowadays. And one of the reasons might have been concluded by Melvin Conway about 60 years ago in 1968 in a paper that he wrote. And one of the things that he wrote, that he concluded actually, is that any organization that designs a system will produce a design whose structure is a copy of the organization's internal communication structure. In other words, he's saying that any company that is building a system, the design of the system will be a reflection of the organization of the people within this company. So basically the teams inside of this company, right? And this is what it is, but I'm also interested in why it is like that, right? And one of the things that he also talks about is that the cognitive load one person takes to solve a problem by themselves, so a single person solving a problem, is infinitely lower than two people or more people working together to solve the same problem. And that's because if you're solving a problem within your own head, and you all know that, you have all the latitude to navigate and understand the benefits, the cons, the reasons why you are making such decisions, that when you move into a team, it's already a little bit more difficult because then you got to start talking to your teammates, right? However, it's still doable if you're within the team. But as soon as we start tackling more complex problems, maybe something modern, maybe something as ancient as the construction of the pyramids, oh God, sorry about that. Then we need to start organizing these people in teams as well. Or we need to think of two things beforehand, actually, before we get these people to tackle the problem or to come up with a solution. So before we get these people to work on the solution, we've got to first define what the solution is going to be, because everybody's got to be on the same page. Everybody's got to be working on the same thing. And the second thing is that we got to come up with the design of this solution. And I think you guys can already see that when you come up with a design for a solution beforehand, there are also two other things that are happening that might not be that good. So the first one, most of the times implicitly, is that you're discarding all the other solutions, all the other designs. You're basically saying, this is the best one for this problem. At least I think it is right now, and all the others can be discarded. And the second thing is that now that you're managing, or that you have to coordinate tens or hundreds or thousands of people together, you have a communication problem, right? You gotta, and if I show the next slide, you're also saying that team A, as you can see on the left, doesn't need to closely communicate with team B in this organization. You made them very separate, very distant from each other, and you actually created 6 or 4 levels of people for them to get in contact together. So what Conway was talking about was much more about the limitation of the human ability to communicate that is still very difficult to overcome, because this is our limitations, right? So until we have an implant inserted into our brains where we can communicate through our minds, we're going to be facing this problem. And if you go back in time to traditional companies, and some companies do still have, or maybe many companies still have this kind of a structure internally, they were actually using the structure that they already had in these companies, right? So they use it to silo their employees by specialization. And when they started having IT departments, they kept doing the same thing. So you would have like system analysts, front-enders, back-enders, DBAs, operations, you name it, all separate in different teams. Have you guys worked in a company like that? Yeah, just a few people. Cool, that's a good sign. But the result of a company like that is building a system would look like something like that. So you would come up with, let's say, 3 applications. So the presentation, the application, the database. System analysts would come up with some documentation that would be laying around. Operations would come up with their things, their servers, and ways to run all of that after they were thrown over the wall to them, right? Which is totally fine, to be honest. I mean, there's nothing wrong with that, especially by the time where it was so popular. But nowadays, but before I actually say this, what I mean is that nowadays, the IT departments of companies are not seen as a support department anymore. It's seen as a strategic department within the companies. And that's because nowadays technology has become part of the core of organizations. And you can see, for example, that today we're having Amazon Prime Days, and probably these are one of the most important days of the year for them. They're going to make a lot of money. However, if their system goes down entirely, then they're going to lose millions of dollars in revenue, I suppose. And most modern companies that were born, I'm not going to say most, but a lot of modern companies that were born in the digital era with internet, for example, seeing that they had to increment the speed, the maintainability, the resilience, the reliability, all these things that Gregor was talking about in the previous talk. And in order to do so, they understood that they also had to change the way they organize their structure internally, or be born with this way of organizing internally. So instead of separating people by specialization, so let's put all the front-enders together, all the back-enders together, all the people who work with databases together, and so on, they said, let's actually slice our business in vertical lines, vertical business lines, and get the specific people that is required to work, and again, in these parts of the system together so that they can evolve faster, that they can move faster, that they can update faster, and so on, and be more resilient. And as you all know, also, if one part of the system breaks, then the other keeps going on, right? But besides that, there was still a problem. Because even by separating your organization like that, as Conway mentioned 6 years ago, communications is still a problem. You're still saying that these teams are separate teams and they have to communicate across themselves. So communication was still coupled. So for example, if the order management team wanted, or if the business wanted a notification to be sent when an order was placed, the order management system needed to know about the notification system so that it could actually send a request to the notification system and tell them, hey, send a notification for me. And the way we solve this problem, once again, as Gregor described in his talk previously, was by decoupling our communications and following a more event-driven architecture. However, once again, I'm going to emphasize this. Communication across these applications, across these teams, is still a problem. So before we continue, I'd like to make a quick recap of everything I talked about so far. So we need to release faster than ever before because everybody's connected. If you guys enter Amazon, for example, and it's not working, you're going to go somewhere else like bol.com or another website, right? This forced us to reorganize our teams so that we could reorganize the design of our systems because it's a reflection of the way we organize our teams. However, communication among humans is still limited to the cognitive load humans can load. The same way I'm talking to you right now, whatever is inside my head, I cannot pass to you 100%. I'm doing my best to do so here, right? So communication across teams will always exist. So you can reorganize these teams the way you want. They still are going to have to communicate among themselves when solving complex problems that require communication. And that led us to AsyncAPI. I think I mix up here the mic somehow. OK. So AsyncAPI was created in 2016 at Hitch by Fran Mendes, a software developer there. It was inspired by OpenAPI. Have you guys used OpenAPI? Raise your hands. I think everybody. Yeah, that's cool. What about AsyncAPI? Have you used it before? Just a few hands. Just a few hands. OK, like 1/5 of the room or something. That's really nice, actually. But what happened is that he started noticing a problem within Hitch, and he started realizing that it was a problem that was happening in the community as a whole, right? Everybody, or many people who were working in event-driven solutions, they were facing the same problem, and this problem was the communication between the teams. And what he came up with was, OK, we have OpenAPI for synchronized APIs. What if I can build the same for asynchronous APIs? And how does it work? So it's a spec file, right? Just like OpenAPI, it's a spec file. You start by defining the AsyncAPI version that you're using, and then it kind of separates into 5 root elements. So you have the information, the server, the channel, the operations, and components. And all of this is application-centric. So we're talking about a single application of your company here. So when you're talking about information, this is the information of the application that is describing the way they use the asynchronous API in this organization, right? So in this example here, this is a Pegasus. The name of the application is Pegasus. The description is that they provide information about bookings. It's maintained by the Ego team and other information as well that you might find useful for anybody using this documentation. After that, you can come up with the servers that this application communicates with. In this example, I have 2 servers. Both of them are Kafka. I have a production and a staging. It didn't have to be like that. It could be 2 production brokers. It could be an internal one and one of a client that you have to communicate with. It could be a Kafka one. It could be a RabbitMQ one. It could be even something that doesn't exist, that only exists inside of your own company, a local-made solution. Because this is agnostic. It doesn't know what are the brokers that exist. You can write anything here, basically, for your documentation. And after you have defined the servers, you can come up with the channels. So if you use Kafka, you probably call channels topics. If you use RabbitMQ, you probably call them queues or exchanges. If you use Redis streams, and I'm curious, does anybody use Redis streams? Nobody, OK, not popular at all. Yeah, you call them channels. And well, channels is where you send your events to or read events from, right? And you can see in this example that we are defining 2 channels, so the flight bookings and the passenger check-ins. And we're also defining for each of these channels the servers that they communicate with and the messages that they either receive or send into these channels. Then we have the operations. And the operations are, again, application-centric. So when you're talking about operations, you're now getting the channels and say, OK, within this channel, this application is going to send messages. And for this other channel, this application is actually going to receive messages. You can define them like that. So you can see that on the top of the example, you have action, and this is send. So it's saying that this application, the Pegasus application, is actually sending messages that is referred also right there, the booking confirmed message, into the channel that is the flight bookings. And it's consuming messages from the passenger check-ins channel. And the message that it consumes from it is the passenger checked-in message that you can define later using a subset of components. So basically, everything that is reusable inside of your spec is called components. And you can have there the messages, the channels, everything that you can define once and reuse in multiple places of your definition. Then you have the schemas. The schemas is what the message, the payload of the message is going to look like. So here we have two examples. You can also define the format of the schema. So here we're using the Avro protocol for those. And then we're also defining what this message or this payload looks like. So we have booking ID, flight number, cancellation reason below, or passenger name, departure, airport, and whatever you need for your message to be used for your systems to communicate well together are going to be defined here. And then from these schemas, you're going to add them as payload to the messages. You could also define the schema right here. It wouldn't be a problem, but it is not considered a good practice because you can always reuse these schemas for other messages as well. So here we have defined the three messages, so the booking confirmed, the booking canceled, and the passenger checked in with the schemas that we had defined previously. In AsyncAPI 3.0.0, they also added the support to the reply request pattern. There should have been an example there, but it's not. But you can think of it as just adding a reply tag or a reply section within your AsyncAPI spec, and then you're basically saying that for that specific operation, whenever something is sent or received, we're going to send a reply there. So basically a request-response pattern that, to be honest, not everybody's fond of within event-driven applications. Oh, sorry. Sorry about that once again. OK, and finally, I'd like to show you AsyncAPI Studio before we actually continue. OK, not this. And here we are. So AsyncAPI Studio is, let's say, Studio in an editor that you can use provided by the AsyncAPI organization itself, where you can define your specs on the left side and then see it rendered on the right side. So you can see that for everything that we defined together in the examples before are now being rendered as a nice UI here on the right side. And the reason why I'm showing you this, so you can see the application information, the servers, the operations, and within the operations you have also the channels and the messages. You can see examples for the payloads here. But the reason why I wanted to show you this is to say that the AsyncAPI spec objective is not just to be readable by humans, but also by machines. And this is an example of that, a very simple example where AsyncAPI is being used for rendering a nice UI that people can use to share their documentation across teams. However, you can also build any kind of application that you can come up with. I've heard that last year, not sure if this year, there were some people from Microx around. Are you guys here in this room? No? All right. So they built an application that uses AsyncAPI as well to generate some code for developers. And another application that's been built from the AsyncAPI specification file is Springwolf. Not an application, actually, a library that goes with Spring Boot. And the idea of this library is to automate the generation of the documentation with AsyncAPI, right? So it was created 3 years after AsyncAPI was invented by Stav Shamir. It is inspired by SpringFox, so it's analogous to SpringFox for OpenAPI, Springwolf for AsyncAPI. It's been downloaded more than 500,000 times. It's compatible with Spring Kafka, Spring Cloud String, and also JMS, Stomps from WebSockets, and other protocols, SQS as well. It has monthly releases, and it has a strong and open community. And I'm going to emphasize that because when we decided to start using Springwolf in production for our systems last year at the company I work for today, they didn't have support for Avro files, for example. And I opened an issue, I started talking to them, and the following month, it was released. And I presented this presentation in May at Spring I/O in Barcelona, as well. And one of the things that I mentioned, and maybe I was a little bit harsh by mentioning this, is that the UI that they provided was could also be improved a little bit. I didn't say with these words, I said ramped up or something like that. But to my surprise, they actually changed the UI. Not sure if because of that, but it was actually nice to see that happening. And they're pretty much strong. This is supported by a small group of people. I think those were the ones that were supporting this application at the time. And I think there are more people supporting it now. And they're pretty consistent. That's pretty cool. So what does it do? It automatically generates the documentation for you based on the AsyncAPI spec. And it does it by listening to code that already exists in your software. So for example, if you're using Spring Kafka and you're using the Kafka listener annotation, it's going to scan your code and look for the methods where this annotation is used and come up with a documentation based on that. But not only that, because if you use the Kafka listener annotation if you're listening to messages, but if you're publishing messages, then you don't use any kind of annotations. And for those, for example, as I'm going to show later, you have to add a custom annotation provided by Springwolf. I'm going to show you later. It's also AsyncAPI compliant, so whatever it generates, you can use in any other application that relies on the AsyncAPI specification. Besides that, it has an interactive web UI, so right from your application, you can see the documentation. Other people can also, from other teams, let's say, can also check the documentation from your application, and you can check from theirs. But the feature that I like the most, and was, for me, the actual reason why I wanted to start using Springwolf is because it also provides message publishing right from the UI. So I could start testing my application without having to worry about having something like AKHQ on the side or a different application just for sending messages into my Kafka broker, let's say. And it would generate the example, the payloads for me, and I could just use these payloads that were generated to send the messages to my brokers. So, little demo time. Too small, right? So to get started with, can you guys see it? Cool. All right, you just have to add 2 dependencies to your Gradle or Maven file, one for the documentation generator and the other one for the UI, as I did it here. They're on 1.7.0 version right now. And after that, you can go to your application properties and start defining some information that is required or that we talked about before. So here you have this information that is basically global from your application. So the information, the servers, and also the configuration for the messaging publisher. So you can see that I can even use the schema registry here. It's going to work just fine. Probably they're just using Spring Kafka within it as well. And what I did is I came up with some messages just like the ones from the examples in these Avro files. Not something fancy, just to showcase. So the passenger checked in, as we saw. And after that, I came up with the listener. So this component, we are implementing 2 listeners here, one for the confirmed bookings topic and the other one for the canceled bookings. And here we specify the message that are going to be consumed from each of these topics. And I don't have to do anything else here. Springwolf is going to detect, it's going to scan my code and understand that those topics are actually, that they should be documented. And I also have a publisher here. And here, as I mentioned before, they also provide these annotations that you can use to add information that is not explicit from your code base. So in this case, for example, I'm saying that this is a publisher and this is the operation that should be documented. Also the same thing for the send, book, and cancel. And then I have this exposed listener just for us to test everything together. It's not part of my business, but I wanted to have it so we could see it actually working. So this is already running. Made sure because I didn't want this presentation to become a troubleshooting presentation. So I wanted to make sure everything was working before. And if I come to this endpoint, Springwolf/docs, I'm going to see how the AsyncAPI file is generated. I can even copy it and take it to the AsyncAPI Studio and see it working here. So basically, it's AsyncAPI compliant. That's the truth. And besides that, I can also come to this URL, which is Springwolf/AsyncAPI-UI.html, and see the UI provided by Springwolf. So you can see the information of this application, the servers that it communicates with, the channels that it uses for its operations, and also the operations themselves. So you can see that we have the passenger checked in. It's a receive operation. We have the examples here as well. And the coolest thing is that I can publish right from here. So if I click on publish from this example and go back to our application, you can see that it was consumed. And that's pretty much it for Springwolf. I just wanted to say something else before we wrap up, which is what's next. So first of all, try it out. Go to springwolf.dev and test it yourself. Try to see if it's going to help you guys within your organizations as well. And besides that, contribute to the project. They're super friendly. They're looking for contributors. At least they were. They answer everything very quickly. They have a Discord channel. So if you guys are looking for an open source project to contribute for, that's a very good candidate. And just to wrap up, my name is Raphael De Lio. I work as a software consultant at Xibia. I'm an AsyncAPI ambassador. I'm the organizer of the Dutch Kotlin meetup as well. And we're having another meetup tomorrow in Amsterdam. So if you guys are around, don't forget to check it out. It's cool. There are going to be 2 interesting talks there. And I'm also a knowledge sharer. I'm on YouTube. I'm on Medium, dev.to. You can find all my information in this QR code. Thank you very much.
All systems are nominal. Initialize Genesis sequence.